Okay. Let's consider this problem. This problem is the kinetics problem in rectangular coordinates. Uh, for this system, this is a pulley system connected with the motor A and motor B. Motor A draw the cable with the acceleration of 3 foot per second square, and motor B draw the cable with the acceleration of 2 foot per second square. First of all, to solve this problem, we have to consider the kinematics of the system first. That is the kinematics of the cable. That is related to the topic of absolute dependent motion analysis. To this topic, we have to find the point that it should be the reference point. So for this, we found that we have this position should be the reference for the vertical cable. That is, for this case, if we set up this as the datum, okay, so the reference, that is the green line like this. So we set up the cable. The first one is maybe SD palm, okay, and this is maybe, if we measure the cable to this position from the reference, we may see that it should be SC, and we found that it should have two sides, that it should be SC also, okay. But from another side, okay, if I set up this position is at the point D, and this is point D palm, okay, so the cable that is measured from this to D, that is SD, and the cable line that is measured from the datum to D palm, that is SD palm. So this maybe draw like this is green line, this green line is SD and SD palm, and you see that it should be the constant when the motor, when the cable is moved into the motor. So SD and SD palm is still has the same length according to this picture. And also don't forget to set up another reference for each pulley in horizontal line, okay. So if we set up like this, so from point D palm to point P palm, so we have SP palm, this is SP palm, okay. And so from this point to point P, we have SP, okay. And according to the datum that we set up, we have to note that SD, SC, and SD palm, okay. So downward is the positive one, okay. But for SP palm to the left is positive one. But SP to the right is positive, okay. So according to this, based on the absolute dependent motion analysis, so we have to starting with the kinematics of, we starting with kinematics. Oops, sorry. Kinematics of the pulley system. Okay, So we found that we have the length SP palm. This is the first one. SP palm. This is the first length plus SD palm plus 2SC plus SD and plus SP is equal to L. That is a constant. That it should be one constant. So that means that we consider the cable is this line plus this line and this, and also this line, okay, and this, okay. So according to this, the all of this 10 of the in the cable sum up, it should be a constant L, okay. After we take the second derivative to this equation, I may define this should be equation A. To equation A, okay, and we have to note that SD palm and SD is constant, okay, it is constant. So that means the derivative of SD palm and SD should be 0, right? So according to this, we obtain the relationship. After we take the second derivative to this, we obtain the relationship of the acceleration AP palm plus 2AC plus AP equal to 0. This is the relationship of the acceleration at this point, this point, and also this point, okay. So, and we can assume that because we consider the acceleration AC mean that the accelerations of the plane, this point, but it is connect with only one cable with the crest, so it should be the acceleration of the crest also. So according to this, from the problem, we know that AP palm is equal to 2 foot per sec square, and AP equal to 3 foot per sec square. So then we substitute AP palm and AP into this equation. So we get 2 plus 2AC plus 3 equal to 0. So we got 2AC equal to minus 5. And then it means that AC equal to minus 2.5 foot per sec square. Okay. So what does it mean? The negative sign is mean that the acceleration of C is opposite to the positive sign convention that we set up, because the datum is over here and we measure the point C from the datum, so it means that go down is the positive, but the acceleration that we determine is negative, so it means that the acceleration of point C should be go up. So the absolute value, the magnitude of the acceleration is 2.5 foot per sec square, and it's go up because it's negative. Okay, right now we have the acceleration already. Okay, that is the first question. The first question determine the acceleration of the 400 pounds. Okay, so this is the first question, first answer. Okay, after that we have to consider the free body diagram and kinetic diagram of the crate, because we would like to determine the tension. Okay, the tension in cable. So we have to consider the free body diagram of the crate. This is if we consider this to draw the free body diagram, we found that we draw the free body diagram. We obtain like this. This is the free body diagram. This is the crate. Connect with the cable. That is should be, if we cut the cable over here, we found the tension. Actually, it is the same cable, so it should have the same tension. But when we cut off at this position, we will see that the pulley has two tension, has two cable over here. We caught when we cut off. Okay, and the weight of the crate. Okay, and it's equal to, this is a free body diagram. And if we consider the kinetic diagram, okay, so for kinetic diagram, it will be up to you. That's right now we know that from the kinematic equation, we know that acceleration AC should be go up. So we can define upward. The motions of the crate should be goes up. Okay, if we define like this, so AC should be goes up. Okay, AC goes up as a positive one if it goes up. So we mentioned that we define it in opposite way when we uh, determine the acceleration at the first time, because the acceleration we determine from the absolute dependent motion analysis. We have to set up the datum, and we found that that one is positive. But right now, after we have the acceleration, we can determine the acceleration already, and we found that it goes up. When we draw the free body diagram and kinetic diagram, we can set up it to the same sense of the physical meaning. Okay, so if we set up like this, so it means that upward goes up is positive. Okay, goes up is positive. So for the kinetics, if we consider the kinetics and we set up the sign convention goes up as a positive, we set up goes up, follow the the motion of the crate, that it should be goes up, as we already found from the accelerations of the crate C goes up. So according to this, we form the equation of motion that is based on Newton's second law. We found that summation F equal to MAC. Okay, and goes up is positive, so it means that 2T is goes up, so it's positive, minus WC. Let's go down, it should be negative, equal to MAC, that is goes up. Okay, so according to this, we found that 2T minus 400 pounds. Okay, equal to mass. So in US customary unit, that is in foot pounds unit. Okay, so the base unit is the weight, not mass like the SI unit. So according to this, we know weight. So we have to determine the mass. The mass is determined by the weight divided by G. G in foot pounds is equal to 32.2 foot per sec square. Okay, so we have to divide it by 32.2 first because it in foot pound units. And acceleration AC, right now we know already it should be 2.5, goes up. Okay, so from this we can solve from this equation. We can solve for the tension. By solve this equation, we obtain the tension is equal to 201 and 215.53 pounds. Okay, this is the answer. Okay, this is the second answer. So let's solve this problem.